Hello everyone. Today I am going to discuss the next term called as Carbanian. In last lecture, we have studied about carbocation. Carbocation, its generation, its reactions, its stability and number of molecular rearrangement. In this sequence, again we have to discuss the next ionic species called as Carbanian. It is a negatively charged species. So let us start with this Carbanian. Okay. First point is that is about definition. An ionic species which carries negative charge is known as Carbanian. Okay, it is represented as R minus. Okay, as far as alkyl groups are considered, when this Carbanian is attached with number of alkyl groups, when these alkyl groups are number equal to 3, it is called as tertiary carbonian. When it is attached with 2 alkyl groups, it is called as secondary Carbanian or 2-degree Carbanian. And when it is attached with only 1 alkyl group, it is called as a primary Carbanian. Okay. Now tertiary Carbanian, it is represented as like this. This is as secondary as here, and first is about that is Carbanian. Okay, now we are going to discuss its first structure. What is its structure? Its structure, it exists in 2 forms. First it is in, that is represented as okay. This structure is having the geometry that is pyramidal shape. Okay, and when orbital diagram is considered here, it is as follows here. That is, this is a Carbanian. Here X, Y and here J. Okay, this is a lone pair of electrons with sp2 hybridized carbon atom, orbital diagram of Carbanian. Here the carbon atom is a sp3 hybridized. In simple form, when Carbanians are considered, they are existing as a pyramidal shape with a sp3 hybridized state. But when this sp3 hybridized state is resonance stabilized, at that time, this is the structure of this Carbanian, which is of a sp2 carbon atom is having the hybridization that is equal to sp2 hybridized state with one lone pair of electrons. Here also one lone pair of electrons. Okay, now we will discuss its properties. First one is properties. First one, it is a negatively charged species, charged ionic species. Second, it contains 8 electrons Third, it acts as a strong nucleophile. It acts as a Lewis base. Okay, and it can attract or pulls towards the electron deficient species. Acts on double bond electron deficient species. 6. In normal form, normally it is sp3 hybridized with pyramidal structure, and with in resonance stabilized it is of sp2 hybridized planar structure. Trigonal planar as a structure. First of all, what is the properties? It is a negatively charged ionic species. It contains 8 electrons. It acts as a strong nucleophile. It acts as a Lewis base. It acts on double bond electron deficient species to get the more stabilized carbocation, and also it normally is present in sp3 hybridized state, which is pyramidal in shape, and when it is resonance stabilized, it is in sp2 hybridized state, which is in planar structure. Now we are going to discuss its generation. Generation of carbanion. First, the direct method is that is by abstracting a proton from given organic species, given organic compound as, for example, first one example is, it is paranitrotoluene. When it abstracts a proton in presence of certain base, here CH3 can be written as here H, this proton is abstracts, there is formation of a carbanion. Okay, this is a carbanion. Now the bases are used as, first is NaOH, NaOR, NaOAT, etc. These bases are used to abstract a proton containing active methylene group. Second is by using, this is the first example. The second is the cyclopentadiene, abstraction of proton here. This proton is abstracted, and there is generation of a carbanion. Okay. Carbanion. Okay. The name of the compound is that is this is what 5-membered, what that is pentadiene. Okay. Now in this structure, the base abstracts the proton and there is generation of a carbanion. In simply, here second method is that is by using alkyl halide. Simple example for generation of a carbanion is, if we take CH3Br here, by breaking this bond or cleaving this bond, here carbon atom retains its lone pair of electrons, and thus it is a negatively charged species. CH3 negatively charged plus Br. Okay, thus here generation of a carbanion. Okay, now second method is, that is from unsaturated compound. Unsaturated compounds. For example, here CH3 CH2. Okay, unsaturated compound, here CH3 CH2 plus addition of a nucleophile 1, here formation of a carbanion. So here CH3 CH2, here nucleophile, thus generation of a carbanion. Okay, now next step is about how the carbanion is generated by use of another process, such as that is, the second method is that from a carbonyl compound. Okay, second method is from, that is carboxylate ion. And third method is from carbon metal, that is from carbon to metal bond. Okay, now we see the first method as carbonyl compound by taking the example of CH3, here CH2, here H, CH double bond. This proton is abstracted by means of the strong base. Here there is formation of CH2 CH double bond O. Okay, that is the carbanion of a ketone. CH3CHO, that is called as an acetaldehyde here. Now the carboxylate ion here are C double bond O here and O. Okay, this electrons goes on here. Okay, these electrons goes on here. Therefore, there is formation of negatively charged plus decarboxylation. Decarboxylation step is carrying out in this in carboxylate ion here. Thus, there is formation of a carbanion. Third is about a C metal bond. That is, suppose this is a C metal bond. When it is cleaved, that is equal to this fashion, there is formation of this carbanion here plus metal as a positively charged. That is of a carbanion. Thus, by using the number of methods, we can generate the carbanion. Okay, first by using, that is from alkyl halide. Second by using, that is from proper proton abstracting. Third by using the carbonyl compounds, carboxylate ion by decarbonization, and here from carbon and metal bond. Now, next point is that is about the stability of the carboanide. Here, first we are going to discuss, that is first stability of carbanion. Here, stability is explained with the help of the important points. First is inductive effect. Okay, and second one is the resonance effect. Okay, now first we will discuss about the inductive effect. What is an inductive effect? that is the permanent polarization of sigma covalent bond due to its adjacent sigma covalent bond is known as the inductive effect, which is a permanent effect. Also, we can take the example of here, that is, due to this inductive effect, there are two types. First is plus I effect and second is minus I effect. Which effect is called as plus I effect? That is electron releasing groups. Releasing groups when are present, it is called as a plus I effect, and electron withdrawing groups. Withdrawing groups such as OH minus, Cn minus, CO minus, okay, that groups are when present in along with the negatively charged carbon with its lone pair of electrons here. At that time, negative inductive effect we can call here. Okay. Now, due to this inductive effect, that is due to the negative inductive effect and minus M effect, which stabilizes the negatively charged Carbanian and thus increases its stability. See here, that is from here. First is Cl, C, L, Cl, okay, which is greater than, that is of Cl, C, Cl of AH, then which is greater than, it is of Cl, C, here H, okay, thus, and here there is formation of thus CH and CH3, okay, thus this is a tertiary, this is a secondary carbanian, this is a primary carbanian, and this is a methyl carboanion. Thus, as the electron withdrawing groups are more, here it stabilizes the negatively charged of this carbanion, and which is get stabilized by this presence of this negative groups, which in thus we have said that it is negative inductive effect which enhances the negative character of this carbanion, thereby increasing the stability of a carbanion. Thus, the 3 degree carbanion is greater than that of 2 degree, that is greater than that of 1 degree carbanion. Okay, now in the next example, that is we are going to discuss. The next example is that is about the electronegativity. Second example is about electronegativity. What is meant by electronegativity? The ability of an atom to attract the shared pair of electrons toward itself and becomes a negatively charged species. The phenomenon is known as the electronegativity. More electronegative character is present along with this carbanion, which enhances the stability of a carbanion. In electronegativity, as far as this term is considered, it is increases with the number of S character. As the percent of this S character is increases, that is from sp3 to increases from sp to sp2 to sp3. Here the stability of carbanion is increases along with also in this fashion. Okay, that is electronegativity or S character is increases, but sp is greater than that of sp2, that of greater than the sp3. For example, that is CH triple bond C with negatively charged, it is greater than here, which that is a acetylene linkage, that is ethyl. Here this is a acetylene linkage, okay, which is greater than that of, it is a ethanide linkage, that CH2 double bond CH, negative charge electrons here, and here CH3 here and CH2. Okay, this is this is of a ethyl, this is of a alkyne linkage, this is of a alkyl linkage, this is of a simple alkane linkage here. Okay, thus there is formation of a increase of a hybridization character, that is of sp. Here is the sp is greater than that of sp2 is greater than the sp3 character. That is, as the percentage of s character is more due to the symmetrical shape of, that is a spherical shape of a s orbital, which attracts the electrons towards itself. Due to that, therefore electronegativity increases with increase in s character, and as electronegativity increases, that is due to the presence of electron withdrawing group. Thus electronegativity increases the stability of a carbanion. Okay, now the next point, that is the resonance effect. Third point, that is the resonance effect. Already we have seen in the carbocation that number of resonative structures are more is the stabilization of a carbocation. Likewise, that more is the number of the resonance structure will disperse the negative charge on each of the carbon atom, which thereby increasing the stability of carbanion. See here, that is CH3, CH, CH2. Here CH3, CH, CH2 here. This is negative charge here on this, that is CH3. This negative charge on here, and there is CH2, CH, CH2. Negative charge on here, and sorry, this on here, and this is on here. There is formation of which is, that is CH2. Okay, CH here, and here's formation of this CH2. Okay, thus this is of a alkyl compounds. In aryl compounds, what is the example? That is ethyl benzene. Methyl benzene of here, that is equal to this. When this negative charge are on dispersed on here, this formation of the structure like this, double bond CH2 here. Okay, this is on goes on here. Okay, then which is the structure of here? Next structure is that double bond CH2. Then these bonds of electrons goes on here. Here acquires the negative charge here. Okay, therefore these electrons goes on here. Okay, that is these electrons goes on here. Now what happens here? Thus there is formation of, okay, when these on goes on electrons, these on goes on here. Okay, there is formation of this structure. On this there is a negatively charged. Again at this step, this on goes on here, this on goes on here. There is formation of the structure as like this here, and electrons goes on here. Okay, this is of CH2. Now these electrons goes on here, these electrons goes on here. That gives rise to the structure here as like this, that is CH2 minus here. The structure is represented as here, that is as like this. That is, thus number of resonative structures are more, the stability of carbanion is also a more. This is the first, this is the second structure, this is the third structure, this is the fourth structure, this is fifth, and this is about the final structure. Final structure, that is alternating double bonds position can be displaced due to the negative charge present on that particular carbocation, which enhances the stability of the carbanion. Okay, thus we have discussed here, that is what is meant by carbanion, how it is generated, what are its properties, and the stability of carbanion with respect to this. First is electronegativity, second is resonance, and third is about inductive effect. Okay, in next lecture we are going to see some reactions of this carbanion. Okay, thank you.